Welcome to Python for Data Science with the DevMasters. This is our section on how to use Python when practicing data science. In this session, we will start with a short introduction to Jupyter Notebooks and how it allows to write Python code. Then we will review Python basics such as data types, variables, operators, control flows, loops, and functions. Lastly, under data structures, we will investigate lists, tuples, dictionaries, and sets to finish off the basics. Then we will move on to pandas, a very popular package for dataset manipulation, as an introduction to how to deal with data. The DevMasters has chosen to teach Python in regards to data science. Python is truly a scripting language, which means you can create projects end-to-end without leaving Python for another programming language. Also, Python is open source, which means no hidden fees or extra software to download. Lastly, it's easy to read and learn. Syntax makes it preferred in the field nowadays. To write Python code, we will be using Jupyter Notebooks. Jupyter allows us to run both Python code and a language called Markdown, which is good for taking notes. Also, Jupyter allows us to import many of the various scientific libraries that are mostly used and important for data science. Notice the changes when we switch between Python and Markdown in Jupyter. Lines of code have hard brackets, and a number appears inside the brackets if the line of code was run successfully. Whenever you are writing in Markdown, there will be no hard brackets for the line of code. Here are examples of Markdown before and after you run them in the notebook. Hash signs create titles, and the more hash signs you add, the smaller the title gets. For italics, place either a single asterisk or underscore at the beginning and end of the text. For bold, place either a double asterisk or double underscore at the beginning and end of the text. You can combine both italics and bold. You can also create unordered lists by pasting an asterisk and a space before the text. For a numbered list, place a number 1 with a period and a space before the text. These are a few shortcuts that'll help keep you organized as you write Python code in the Jupyter Notebook. Also, if you need to stop or restart the kernel, we show you how to do so by clicking either the stop or refresh button. When writing Python code, it is important to understand the different data types. We have numbers, which can either be integers or floats. Integers have no decimals and floats do contain decimals. Another data type is strings. Strings are initialized by putting single, double, or triple quotes at the start and end of a sequence of characters. Slicing strings is an important technique for data science. Here we initialize a variable and then we slice through it using different techniques. The hash signs are comments to show the technique we did in that line of code. Like any language, Python has variables. We use variables to store info so we can access them later on. Here are some rules to follow when writing variables in Python. Variables are case sensitive, so keep that in mind if you have to do any comparisons. Avoid using reserved Python words for you variables such as break, import, for. Camel casing is a good rule of thumb to follow when naming variables. The second example is an example of camel casing. The first letter is not capitalized, but all the other words that follow it are. This helps with the readability of your code. We will need this list of operators to do mathematical calculations in Python. One thing to note, if you are running Python 2.7, if you divide 5 by you will get 2. but if you are writing in Python 3 you will get 2.5. Modulo is help when we are trying to find the evens or the odds in a list. Here are a few examples using the operators. When we want to compare items or values in Python, we will need to use these comparison operators. Be careful when using your equal signs. A single equal sign we use to initialize a variable. The double equals sign will be used to compare two values to see if they are equal. Here are a few examples using the operators within Jupyter Notebook. Notice the outputs are booleans, true or false. This is different than our output when we make calculations. When making calculations we get some value, rather than true or false when making comparisons. The three control flow statements in Python are if else, and else. The if statement is used to check for a condition. If true, the block of code runs. If false, the flow either continues to an if-else statement to check another condition, or it continues to an else if there are no other conditions you want to check besides what was written in the if. If this is your first time learning a computer programming language, it is a good habit to write out your steps in Word. Then turn your steps into Python code. This process is what we call writing pseudocode and is a practice that can help you learn easier and faster as a beginner. In Python there are two types of loops. We have a for loop and a while loop. For loops are preferred when we need to integrate through a sequence of values. A while loop is preferred if we want to execute a block of statements multiple times. Be careful when writing while loops and do not write any infinite loops. Just interrupt the kernel and restart if this happens. To write a for loop in Python we use the range function. We can give it both a start and end value, but if we give it one number it uses 0 as the default start number, and the number you pass as a parameter as the end value. For a while loop we give the loop a condition to run the loop until the condition is met. It is essential for the while loop to have a counter variable, so you do not run into any infinite loops. The first data structure we will look at is lists. Lists are very common to use when practicing data science. They are mutable, which means we can add, remove, or update any of the values within the list. We initialize them by using square brackets. All data types can be inside of a list, including other data structures such as other lists and dictionaries. The values inside the list all have an index they can be referenced by. These are methods we can use when working with lists that will help us work with our data. Append allows us to add values to the bottom of our list. Delete allows us to remove values if we know the index of the value. This differs from delete because in remove you will need the name of the actual value rather than the index the value is positioned in the list. Here are our list methods being written in Python within our notebook. Notice the changes in the list for each method, especially with the sort method. Notice how numbers and a numbered list comes before a string. Second, we will look at tuples. Tuples are immutable, which means we cannot change or delete any of the values once we create a tuple. Tuples can be coordinators of a map or a point on a graph denoted by x and y. Tuples are initialized by parentheses and values within the tuple are separated by commas. The third data type we will look at is dictionaries. These are used to store key-value pairs. Dictionaries are also good for when we want to store multiple details about a specific piece of data. For example, the key could be a name, and the values could be another dictionary of key values of occupation, telephone number, family members, etc. Keys must be unique, and values can be any data type. To create a new key value pair, you will have to initialize the new key by naming it and then set it to its new value. You can also find the length of a dictionary using len function, and you could also delete values from a dictionary using the del function. Here are our dictionary methods being written in Python. Notice the output for the for loop on the last line of code. This for loop helps shows all the key values pairs within your dataset. The fourth data structure we will look at is sets. Sets are preferred when we want to test membership, and the order or frequency of the values is not important. Sets remove all duplicates and sorts the values of a list in sequential order from smallest to greatest. Here are the methods we will use when working with sets. We use int to test for membership within a set. A true or false result is returned. Add adds a value to the set. Remove gets rid of the value useState. Intersection shows what is similar in both sets when finding the intersection between two sets. Difference shows what values are in one set and not in the other. Union combines all the values of two sets. Here are our set methods written in Python. Notice the results when using these methods. In Python, we can write functions which are reusable blocks of code you can run anywhere within your notebook. Think of them as a black box where we may pass values and get a value in return. We can also write lambda functions, which are functions you can write on one line. Pandas is commonly used because of its helpful data analysis tools. These tools give us the power to make insights from our data. We import pandas using Python by assigning it to a variable. Whenever we want to use a pandas function, we just need to reference the variable. If you want a list of all the functions within pandas, there is a quick shortcut to check. Type the variable name and a period, then press tab. A drop-down will appear, and you can scroll through and check all the functions in the library. Also note how to import pandas and how we can create a data frame. We will be using this data frame to test out some of the pandas methods. While scrolling through the library, notice the different file types you can read and write to. Data can be saved many ways, such as a database, Excel spreadsheet, or CSV file. Using Python, we can read in the data into our Jupyter notebook for analysis. We can also use Python to write our data back out in these file types as well. Once we have imported the data, we start our analysis by gathering a basic information about our data frame. There are many functions within pandas that can help us gather this info. Shape gives us the exact number of rows and columns. Index informs us how the data is indexed. Column gives us the names of each column. Info give us a great summary of the data, which includes the data types, column names, and total number of record in each column, total number of entries. Count is helpful for finding the number of null values. These are the outputs we would receive as we use these methods on the data frame we created at the beginning of the session. If we want to dig further into our analysis of the data frame, there are functions that give us statistical summaries about our data. Sum adds up all the values in whatever column you designate, and it returns the calculated result. Min and max are helpful when finding the lowest and highest point of our data. Describe gives us 25, 50, and 75 quartiles as well as the min, max, and standard deviation. Mean finds the average of values. Medical takes the middle of the values, and if there is an even number of values, it adds up the two values and divide by 2. If we want to select a specific row and column within our data frame, we can do it by the position, label, or combination of the two. For just the position and label, we use iloc. When using iloc for the position, we use pass two numbers. One number is the index for the row, and the other is an index for the column. These two numbers are used to select the record we want in our data frame. When using iloc for the label, we pass a number and a string for the column label we are selecting from. To select a single row including both position and label, we use X. This has been Python for Data Science, created by TheDevMasters. We hope this has been a wonderful beginning video to help those who are new to data science or new to using Python for data science. For other videos or examples, please visit us on our website, thedevmasters.com.